We are our microbes. Did you know that between 10 to 100 trillion microbes, bacteria, viruses, and fungi live almost as partners inside our bodies, primarily in our intestines? These microbes, together with their genes and the surrounding cells, are known as the microbiome, which is considered our second set of genes, and it is involved in many of the essential functions of our bodies. In contrast to the human genome, which is inherited, does not change much during our lives and consists of approximately 20,000 genes, the human microbiome is something we get at birth and we shape with the food we eat and places we live. It changes all during our lives and contains approximately 10 to 20 million different genes. Our microbiomes are made of bacteria that we need to be healthy, bacteria that make us sick, and bacteria that mostly seem to do nothing. An imbalance of the composition in a person's natural microbiome, known as dysbiosis, may contribute to a range of diseases, including cancer. What is the relationship between the microbiome and cancer? The human microbiome may be involved in the initiation and progression of cancer in different ways. Viruses, for example, can cause cancer by integrating pieces of their viral genome into human genes. Certain cancer-causing bacteria are found in higher levels in colorectal cancer tissue compared to normal tissue, and are thought to cause cancer in different ways by different mechanisms. Whether direct or indirect, their activity is thought to promote tumour development and growth, as well as its dissemination to distant organs, and affect how a person will respond to treatment. The microbiome as new actionable tool in precision oncology. Future strategies of precision medicine will likely rely on novel diagnostic and therapeutic tools with which to identify and correct imbalance in the microbiome that compromise therapeutic efficacy. These interventions would be adapted according to the patient's lifestyle, diet, comorbidities, co-medication, and genetic inheritance for an optimized personalization of their therapy. In this sense, research will be essential to identify new biomarkers based on microbial composition that may indicate the presence of a tumour or risk of developing one, and of how a person would respond to treatments such as immunotherapy. The optimistic opportunity to investigate the microbiome's impact on the science and treatment in colorectal cancer. Cancer Grand Challenges Team, funded by a grant from Cancer Research UK and with researchers in the US, Canada, the UK, the Netherlands and Spain, is exploring the relationship between the microbiome and colorectal cancer to find new ways to prevent, diagnosis, and treat the disease.